Dear students, welcome back. Today I am going to discuss a very important topic, that is condensation polymers. Condensation polymers are the polymers which are formed or produced by the combination of simple molecules known as monomers. During the formation of condensation polymers, water is given as a byproduct. So let's see the first example for the formation of condensation. Condensation polymers is terylene. So in terylene, you see it is a synthetic polymer. It is not a natural polymer. Synthetic mean man-made. And at the same time, you can be asked what type of polymer it is, addition or condensation. So it is condensation polymer. So now, in order to make this polymer, what type of molecules are required? Those molecules are known as monomers. The two monomers which are repeating in the structure of terylene are dicarboxylic acids and diol. Diol basically it is for hydroxy compounds, also known as alcohols. So whenever these monomers will combine with each other, the linkage formed or the bond formed between these two monomers will be known as ester linkage. I will show you ester linkage when we are going to make the polymer. At the same time, one mark question can be where this polymer is used. It is used for making pillows and jackets. Even you see, we can use it in, blanket, you may say that. Okay, so now all these points I have discussed, they carry 1 mark each. Like say, two monomers, 2 marks. Type of polymers, either synthetic or natural. Synthetic, 1 mark. Addition or condensation, this is 1 mark again. Linkage name, that is 1 mark. These are the points which have been taken from the past papers. Okay, so use or application carry 1 mark. This is a very easy question. You can get all these marks easily. We now come to the structure, how this polymer is formed. This is a polymer, which is a terylene. So in order to make it, let's take an example of two monomers. Although, in this polymer, we have thousands of monomers together. In addition polymers, you might have seen the monomers were identical, but here the monomers are not identical. This is carboxylic acid. This is hydroxy compound. Both are different compounds. Okay, so these are the block diagram. Basically, in the paper, you will be asked block diagrams, but sometimes this box can be asked like this. This box may contain CH2 like this. You can be given with the structure of monomer like this. They will remove the box. You can be given monomer like this. You understand? So this thing basically it is included in the group, the block, sorry. So this is the block diagram of dicarboxylic group. Why it is dicarboxylic? Because it has two carboxylic group in it, COH less. Now this is hydroxy compound. This is known as diol because di means two. There are two OH groups here. You can see this. So when these two monomers they join with each other, condensation reaction takes place. Now in condensation reaction, water molecule is given up as a byproduct. First, I will tell you from where water molecule will be released when these two monomers will combine with each other. Let's see. First, remove the OH of COH from this side and hydrogen from this side and make one water molecule. Then, on the other side of the box, you see we have again OH group, hydroxyl group from the carboxylic group, and H, which is hydrogen from hydroxyl group. They will combine together make this linkage known as ester linkage. C is coming from this carboxylic acid, and this O is coming from this hydroxy compound. You understand? So when they will combine together, they will make a one repeating unit. Keep in mind, in condensation polymers, two monomers are the part of one repeating unit. This is one repeating unit, and this way you can join much more, monomers, but this pattern will stay the same. Carboxylic acid, diol, or hydroxy compounds. So you will get this, repetition in whole the polymer, right? Okay. Now, what type of questions can be asked in this polymer? Number one, synthetic, I told you earlier, 1 mark. Type of polymer, naturals are addition. Yes, natural or, condensation, it is condensation. Then monomers name, then linkage. This is here is ester linkage. As I told you, I will show you. This is ester linkage C double bond. And so keep in mind, when in order to identify, you make it easy that which structure is adenine. You must keep in mind one box has C double bond O on both sides, and other box has both sides. This will help you identify the adenine. Okay, so hope you understand. If you have any question, you can further comment so that I can improve and help you people. Please, if you can subscribe my channel, I will be very grateful. Okay, now let's see the next, polymer that is known as nylon. This is another condensation polymer. So nylon is a synthetic polymer as well. So it is also condensation polymer. Where it is used, it is used for making fishing nets. This is very easy. Parachute formation, parachute very well. The monomers, in order to make nylon, are diamine and dicarboxylic acid. This is diamine, this is dicarboxylic acid. I have shown these monomers here when I will be making polymer. So this is diamine, this is a block diagram. Again, this box contains carbon atoms. As we are not, defined how many carbon atoms are there, that's why it can cover any number of carbon atoms. We will make this block. Both sides of the block, NH2 groups are present. These NH2 groups are known as amino groups. These amino groups are basically attached to the carbon of the blocks. Sometimes one carbon from the block on both sides is shown, so that you can easily come to know that nitrogen is attached to which atom. Similarly, we have another dicarboxylic acid. You keep in mind in tyrrolene and in nylon, this thing is common dicarboxylic acid. In tyrrolene, on the other monomer was diol. Here it is diamine. So only diol has been replaced with diamine. So when these two monomers will combine, the combination will stay the same. In this case, hydrogen from NH2 and OH from carboxylic acid will give us a water molecule. Now, in the center, this hydrogen from this NH2, which is amino group, will combine with OH group from the carboxylic group to make another water molecule. In this way, we will be having two water molecules along with the formation of this repeating unit of nylon. You know why I'm saying repeating unit? Because in this case, two monomers are different, so we have to show both the monomers in the repeating unit. Otherwise, there are thousands of monomers in one polymer. So you see, uh, you can be asked in the paper, mark the linkage between diamine and dicarboxylic acid, or the linkage in the nylon. You will see where nitrogen is there and C attached with double bond O. So you will circle them, okay? So this linkage is known as amide linkage. At the same time, you can be asked, as this is synthetic polymer, name the natural polymer containing the same linkage. You will say protein. So protein will have the same linkage. You understand? So nylon uses are clear to you, monomers are clear to you. Yes, I want to tell you very important thing, and as you know, at the end, sometime this polymer is given, and you have to draw the structure of monomers. So for this, you need to know where they have been linked. So they have been linked between nitrogen and carbon. You will split them, and whatever atoms were removed, you just add them here. Put H here again, and OH here. You will get carboxylic group here separate like this, and NH2 group on this side. You understand? If you have any question, please write in comment box so that I can help you people. Inshallah, complete CIS syllabus will be discussed one by one, topic by topic, according to syllabus. Yeah, at the same time, the past papers on every topic will be discussed after this, condensation polymers are finished, and you will see the solution of specimen papers as well, and last at least 20 years paper. So thank you for listening to my lesson, and hope you will be able to subscribe my channel. Thank you very much.